Okay, so in the last lecture, what we did was the pillars of object-oriented programming. Those were data abstraction, encapsulation, inheritance, and the polymorphism. So now today we are going to work on the importance and principles of modeling. What are the principles of modeling and the importance? So before starting with modeling, we need to understand what a model is. Basically, when we say a model is a simplified representation of a thing. That means if I want to develop a particular thing, product, so before developing that product, I am going to start with a specific design, right? So that the user can understand this particular product before the development process. So that particular simplified representation of a thing is called as the model, right? Now, when we say model is doing what? It is including or it is capturing all the important aspects of the thing which we are designing. When I'm saying a thing, I'm talking about the product I'm going to develop, right? Which is being modeled. And it leaves out the rest of the details which are not necessary for the user. Next, the model is intended to be easy to use. That means final system के comparison में this particular will be the model which will be easy to use. Now, when I say model will have two things. It will have semantic plus it will have notations. Considering that you all know what is the meaning of semantic and what is the meaning of notations, we are using what? We are going to use these particular in various forms of pictures and text. And then with the help of all these things, we are going to design a model. So designing part is coming, modeling is coming under the designing part, right? So when I'm saying I'm designing, so that means I am modeling, right? Now, when a software system is being modeled, and it can be developed with the help of a modeling language. Now, when we design a model for a software system, it can be done with the help of a modeling language. And which modeling language we use? We use UML, which is called as Unified Modeling Language. Now, when I say model, I can give a basic example of the model. That is, whenever a particular house is constructed, right? So we have an architect who can design this particular layout of the whole house. So that particular layout which has been created as a model, so that the person who is going to live in that particular house can get a clear understanding that how many rooms will be there in the house, where the kitchen will be, where the washrooms will be, and how the layout will be presented, how much sunlight will we get, what will be the directions of the rooms, what will be the directions of the doors, main door, windows, etc, 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 right? So before designing, before developing, before constructing that particular house, we are doing what? We are taking a design of that particular house, and that particular designing is called as the modeling, right? So same way, what we are doing in a software system, before developing the software system, what we are going to do, we are going to create a design, and that particular design is the model. Now, we move further for understanding the importance of modeling. Now, we have understood that the process of designing this particular model is called as the modeling. Now, what is the importance of this modeling? Why do we need to have a model? So, as I told you, what is a model? Model is a simplified representation, right? But it is a simplification at some level of abstraction. That means this is very helpful for all the users to get a specific understanding of what the actual product will be after the development. It is getting a clear view. We build models to better understand the system understand the systems we are developing. So that is the basic importance of modeling. Now we can understand it in the points, that is, these particular models help us to visualize. It is very clear. Visualize means that we can easily view this before the development, before the building has been architected, before the building has been constructed. We can have a same view. We can have a view of that particular building before the construction itself, and we can change some few things in the building or in the house if you want to. And same is the concept of the software. So next thing, it is very helpful to specify the structure or the behavior of the software. We are talking about software here. So it is helping us to specify the structure or behavior of the software. Next, it will provide template for building the system. That means it will give you a clear picture and it will give you a basic structure of that particular product that we are going to build. And lastly, we can document decisions we have made. Let's say with the help of the model, when we have designed the model, we have certain features which are to be maybe included or to be excluded or to be updated. Those particular decisions can be documented well here in time. That is, before the development process, we can decide on the certain issues which are to be understood by the user with the help of the model itself. So these are the certain features or certain points which I can say that is important for the modeling. Now, second thing is, what are the principles of modeling? Now, after understanding what is a model, what is the importance of this model, what is modeling, and we are moving towards the principle of modeling. Now, there are four major principles of modeling. They are, first one, the models we choose have a profound influence on the solution we provide. That means according to our choice, which model we are choosing for our software system in the design part, that will make a impact on the solution we are going to provide. That means a specific model can help us to understand all the loopholes of the solution, right? And other model can help us, or it can not help us to understand all the issues which we can face in the later stages. So we have to choose a model which is best suited for our solution. So the choice of the model is very important, right? We have many types of models which we are going to see in the later lectures and later sessions. So we will understand what different types of models we are talking about. So we have to decide and we have to choose the models on a special note, that we have to take care which model we are choosing on. Next one, every model may be expressed at different levels of abstraction. That means, second one, every model we are talking about, all the models can give different levels of abstraction. That means that one model can be helpful for an analyst, other model can be helpful for the developer, because analyst is depending on and he is analyzing what we are designing, what the solution is. So his focus is on, the focus of analyst is on what, right? So a model which is focusing on what, that will be helpful in this region. While when we talk or when we see with the perspective of the developer, we see that how the model will be designed, how the software will be designed or developed. So here the focus is about the how. So we have to take care of all the models, and all the models are providing a different level of abstraction, such as I talked to you about. Analyst is going to focus on what the solution is, on what the solution is. While when we talk about the developer, we are going to focus on, I'm denoting as developer as D, while we are saying that developer is focused on how the solution will be implemented. So here we are talking about two different models which are going to focus on two different perspectives. So this is called as the different level of abstractions. Now, third principle is the best models are connected to reality. That means the best models are the ones which are connected to reality, which can give you all the loopholes, all the possibility of issues which can be seen in the future with the development of the software. And lastly, fourth one is no single model is sufficient. A set of models is needed to solve any non-trivial system. Now, when I say no single model is sufficient, I mean to say that I cannot say that this particular use case diagram is enough for the design part and the development of the software. We have to take care that a set of models are to be included with the perspective of all. Example, if I'm going to work only focusing on what? Only focusing on the status of the state of the process, or I am only focusing on the functioning part, then we will lose the other end and we will not focus on the part which is more important to the analyst. So these are the basic, and I would say four basic principles of the modeling, right?